Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Iqbal Amali bin Alias from class JCS1105G. Today I'm going to represent my group to do a presentation about how we are going to do the subnetting process in the group project that has been assigned to us by our ITT300 lecturer, which is Sir T.S. Ahmad Kamal Zaman. Now let's go straight into it. The title of this presentation is IP address subnetting. First, before we continue with the process or method that we are going to apply, we need to know the number of subnet. From the question that we received, we need to create 8 subnets where 6 of the subnets are used for the department network and the other 2 are for the inter-router connection, which is the connection between routers. Next, this is the number of hosts that are required in each department. As we can see here that the human resource has 28, ICT 23, operation 14, marketing 13, R&D 9, branch office 12, inter-router 1 and inter-router 2 are going to need 2 ports for each of them, which means they are going to need 2 IP addresses. The method that we are going to apply in the subnetting process is that we are going to calculate the subnetting from the highest number of computer or hosts to the lowest. So this is the formula or method that we are going to be using in this calculation of process. First, we are going to use the number of address space, which the formula are 2 by the power of 32 minus n. The n retrieved from the number of the mask from the block of address. Next is the number of borrowed bits. The number of borrowed bits are retrieved from the number of computer or ports that are going to need by implement the log to n. Next is the subnet mask formula. The subnet mask formula typically are used to find the subnet mask for the subnetting. For this subnet mask, this formula we will get into it much more further in detail during the process itself. In this table, as we can see here, there are 3 rows, which is the wildcard, the CIDR, and subnet mask. The correlation between these 3 are the middle one, which is the CIDR, because we retrieve the CIDR from the calculation of number of borrowed bits and the subnet mask. Next, in order to find the wildcard, we are going to implement the first complement, which is the inverse of 1 to 0 and 0 to 1. And the next is the subnet mask, which we are going to calculate the binary and turn it into the decimal point or the dotted decimal subnet mask. Next is the next method that we are going to apply is the number of address available in each subnet. This formula are used to know whether the number of address are enough for a certain department. The formula that we're doing is 2 by the power of 32 minus the CIDR, which is the subnet mask, the mask of the subnet. Next is the formula of subnet X. This formula used to calculate the number of bytes that we are going to add into the first address by minus 1 first. The formula are going like this: subnet X equal to X minus 1. Then the answer from the X minus 1, we are going to multiply it with n. N is the number of address available in each subnet. So in the table below here, as we can see that there are 3 rows also. The first address, the last address. The middle one is actually the wildcard. As we know that the wildcard are used to add between the first address, is add into the first address, and from the result of the addition, we are going to retrieve the last address. This is one of the example where the bytes that are added are 0 in the first address, 200, 0, 41, and 0. The wildcard are 0, 0, 31. And the last address, this is the result of the last IP address, which is the broadcast address that we are going to receive. Next, in this assignment group project, the IP address that we have received is IP address 200.0.41.0 with a mask of 27, and the number of address space that exists in this block of address 256 by applying the formula is 2 power of 32 minus 27. Next, this is we are going into the process of subnetting. The first subnet is for human resource department, as we know that the number of ports are 28 that are needed. The number of computer or ports is 28 computer. From this number of 28, we are going to insert it into the borrow bits. Then by using the formula number of borrow bits equal to log 2. But we cannot use the 28 into the log because it will produce a number with an point. So we are going to use the nearest number, which can produce a solid decimal number like 1, 2, 3, 4, 5. So in here we are going to use 32 because it's near. As it's near to the 28. As it's near to the 28. I'm sorry. So from here we are using to log to 32 is equal to 5 bits. And from here the bits we are going to minus it by using the formula of subnet mask, 32 minus 5. And the mask that we have retrieved are mask 27. As we can see here that the wildcard for this subnet 31 because the subnet mask is mask 27. We implement the first complement method into this CIDR to get the wildcard that is 0031, and then the binary we change it into the decimal number which that we get as for our subnet address, subnet mask, which is the 255.255.255.224. Next, the number of address available in each subnet. Before we go into the plus with the wildcard, we are going to need to know how many address that are available in this subnet 1. So in here we get to see that the number of address available are enough for the subnet because it require only 28 computers, and from here we have 32 address minus 2, which is 30 address that are available within the IP host range. So in this we are going to use the subnet 1 because this is the early subnetting process. So subnet 1 equal to 1 minus 1. Then we get the total is 0, and from here we are going to times it and multiply it with the number of address available, which is the 32, and is equal to 0. The changes that occur in this byte are the last byte, the 4th byte, if I say, because from the early the block of address has a mask of 27. So this shows that from byte 1 to byte 3 are full with the subnet of 255. Then the space that we are going to that can be added or changes the last byte, which is here we put 0 because the product are 0 from this multiplication. So from here we are using the 200.0.41.0 and the wildcard 0.0031, and from this addition we retrieve the last address 200.0.41.31. The first address is actually the network address and the last address are broadcast address. Next we are going to calculate the subnet 2, which is for the ICT department. We can see here that the computer or ports needed in the ICT are 23 computers. So as I said earlier, 23 cannot be used in the log because it will produce numbers with point or numbers with decimal. So we are going to choose the nearest number that are going to produce as a real number, which is log 2 32, which we get 5 bits as the number of borrowed bits. Then we are going to apply the number of borrowed bits into the subnet mask by minus it with mask 32, and we'll get the same answer as the subnet 1, which is mask 27. As we can see here, the wildcard, CIDR and the subnet mask are still the same in the between the subnet 1 and subnet 2 because it require the same it use the same number of borrowed bits. Next, the number of address available in each subnet. As we can see here, that the number of address available are enough for the department of ICT because it only require 23 computer or ports. So from here, we use subnet 2 because in the subnet 1, we already use the subnet 1 calculation. So now we are going to use the subnet 2, and then the formula is 2 minus 1 equal to 1 times 32. The answer is 32. Earlier, we cannot see the much changes in how we change the byte, but starting from the subnet 2, we see that we are going to put the answer of the subnet into the last byte, which is the 4th byte, into the first address, into the IP address. So the first address 200.041.32, and the wildcard that we're using 00031, and the product of the addition that we retrieve is going to be the last address, which are 200, 0, 41, and 63. The answer, the 63 are retrieved from the addition of these two bytes. Next, the subnet 3, the operation. For operation, the number of computer or ports needed are 14, and the number of borrowed bits changes. We cannot use the log 232 because it will be too many, because the question asks for the maximum number of port that can exist in the department. So we are going to use the nearest, which is the log 216, and the borrowed bits are 4 bits, and the subnet mask that we are retrieved from this minus mask 28. The difference between the earlier two subnetting process are the wildcard, CIDR, and subnet mask. The wildcard that we are going to be used in the subnet 3 are 00015, and the CIDR are mask 28. The subnet mask is 255.255.240. Next, the number of address available in each subnet. We are using the same formula as before. N equal to 2 power of 32 minus 28. The 28 is the CIDR itself, and the address that are available is 16. Minus the minus 2, we are going to have 14 addresses available in each subnet. As we can see here, that the subnet 3, the operation department, only require 14. So it's enough for this department. Next, the subnetting, that the number of subnet that we're going is used to subnet 5. Why we did not continue from the earlier? Because the earlier we are using subnet 1 and 2. Why this cannot be subnet 3? Because if you are using subnet 3, the IP address will be overlapped, and the overlap IP address are an error in the calculation of subnet. So we are going to use the subnet 5 because it is the continuation of the IP address. So from here, we are going to use the subnet 5 minus 1. We are going to get the 4, and 4 times by 16, which is the number of address available. And the byte that we are going to add is 64. So from here, we are going to insert the number of 64 into the 4th byte here. And we are going to edit it with the wildcard that we are using. The wildcard that we're using for this subnet 15, and the last address that we're going to get 200.0.41.79, And the first address 200.0.41.64. The next subnet is the subnet number 4, which is the marketing department. The marketing department only need 13 computer ports. So we are going to borrow bits. We are going to use log 216 because it's the same reason as before. If you are using other than if you are using log to the log 2 not if I say not in the range of 2, 4, 8, 16, 32 range, it will produce a number with decimal point. So we are going to avoid it because it is a wrong answer. So technically we are using the 16 because it's linear. As we can say that let it be bigger than the number of ports. The answer that we retrieve for this number of borrow bits are 4 bits. Then we apply the subnet mask formula, 32 minus 4, and we get the mask 28. This wildcard CIDRN subnet mask are the same as the subnet 3 because it required the number of borrow bits 4 bits. I'm sorry. Next, the number of address available in the subnet. We are going to get the same number, which is 16. And from in this subnet 3, we are using the subnet 6 because we are going to continue the number from before. In subnet 3, we using number 5 as the starting point, and here we continue because the number of each subnets is the same and the wildcard is the same, and the number of the CIDR is also the same. That is one of the reason that why we are going to continue with the form of 5, 6. So from here we are going to get the answer is 18, which will be used in changes in byte 4, and the answer and we are going to edit it using the wildcard, which is the 0.0.0.15, and we'll get the last address 200.0.41.95, and the first address 200.0.41.80. Next, the subnet 5, branch offices. The branch offices are going to need the 12 computer or ports in their department. So the number of borrow bits we are going to use log 216, which is equal to 4 bits, and the subnet mask that we're going to get mask 28, and the wildcard CIDR subnet mask are the same as the other the last two department that we presented. So the number of address available in each subnet are 60, and we continue the before subnetting. We are using subnet 7. Then we get the answer of 6 times 16, which is the 16 is the number of address available, and we get the 96 as the byte that we are going to use in the fourth byte. In the first address in the subnetting, we are using 200.0.41.96, and the wildcard are 00015. And the last address that we get from this addition, 200.0.41 and .111. Next is the subnet 6, R&D, research and development. The number of computer or ports that are needed in this department are 9. And the number of borrow bits that we are using is bits log 216. Maybe some of them has a question that if the number of computer or port are 9, why we are not using log 28? The reason why we are not using because when the number of port, the maximum number of port are 9, we cannot go lower than that, because if we go lower than 9, we will get the number of address available much lesser that we can use in the department. So in here we are using log 216 because it is more than the number of computer or ports, and the borrow bits are 4 bits. The subnet mask that we get is mask 28 from the 32 minus 4. The wildcard are still the same and the CIDR and the subnet mask between the last three subnetting. Okay, next, the number of address available in each subnet n equal to 2 the power of 32 minus 28 equal to 16. And then we are continuing again the subnetting from 5, 6, 7, and now we are using 8 subnet at equal to 8 minus 1, that we are going to get 7 times 16, which the answer is 112. The 112 we are going to insert it into the fourth byte here as our first address, which is 200.0.41.112, and the wildcard that we are using is still the same, 0.0.0.15, and the last address that we get from this addition, 200.0.41.127. Next is the subnet 7, which is the inter-router 1. Okay, the inter-router 1 only require 2 ports, and the number of borrow bits that we're using is bits log 24. The reason why we are not using log 22, even though the log 22 can be used because it follows the number of computer ports, this is because if we are using the log 22, we are only going to get 2 IP addresses. So the requirement for this inter-router 1, they are going to need 2 IP addresses that can be used in the topology. So if we only get if we are using log 22, we will only get 2 IP addresses which are used for network address and broadcast address. So it is not efficient. So we are using log 24. So we will get 4 number of addresses in this subnet 7. So the first address we can use for the network address, and the last address we can use for the broadcast address, and the remaining 2 IP address will be used for the router. So from here we can see that the number of bits are 2 bits, and the subnet mask that we're going is mask 30, because we minus mask 32 with 2. And from here the wildcard changes because the number of subnet mask CIDR is also changed, and the subnet mask is changed. The wildcard for this subnet we are going to use are 0.0.0.3, and the CIDR that we retrieve are mask 30, and the subnet mask that are used in the subnet are 255.255.255.252. Next, the number of address available in each subnet. As I said earlier, if we use the log 22, we are not going to get the number of address available equal to 4, but we are going to get equal to 2. That is why we are going to use to log 24 in order to get this number of address available, which is 4 address available. So in here the subnet calculation, the byte that we're going to add into the first address in the fourth byte, we are using subnet 33, because if we are using subnet that are less than 33, we are going to get an overlapping IP address. Next, the continuation of this 33 minus 1, we are going to get to 32 times 4 equal to 138. The 138 we are going to add it into the fourth byte here, and then the first address of the inter-router are going to be 200.0.41.128, and the wildcard that we're using here are 0.0.0.3. These are retrieved from the subnet mask earlier. The last address that we get from this addition, 200.0.41.131. Next is the last subnetting, which is the inter-router 2. The inter-router 2 also going to need 2 ports in their address in their subnetting. So the number of borrow bits is the same, log24. We are using the 4, which is equal to 2 bits, and the subnetting mask is the same as inter-router 1, and the wildcard CIDR and subnet mask is also the same, which are the wildcard are 0.0.0.3, and the CIDR is mask 30, and the subnet mask is 255.255.255.252. Next, the number of address available in each subnet are 4, and the number of address that we can use is only 2, because minus the network address and the broadcast address. The subnet 34 is the continuation of from the interrouter 1, which is subnet 33. So from this continuation, we are going to get the number of byte is 132 that will be going to insert it into the fourth byte. The first address after the changes we made in the fourth byte here, we are going to get the 200.0.41.132. And the wildcard that we are going to use are 0.0.0.3. And the last address are 200.0.41.135. So with that, this is the end of the subnetting calculation. So in order to get the whole picture, we are going to see it in the subnet table that we have prepared. So in here, these are the subnet table for each of the subnet. As we can see here, that the maximum number of computer here and the subnet mask is different for each subnet, and this is the subnet address, which is the first address. As you can see here, that 200.0.41.0, and the last and for subnet 8 is 200.0.41.132. And the last address here, we are using it as the broadcast address, which is for subnet 1 is 200.0.41.31, and for interrouter 2, the last subnet, we are going to use 200.0.41.135. And the number of addresses for each subnet are different, because it based on the maximum number of computer. So from here we can see that when the number of hosts are more than 16, we are using the 32, and if less than or equal to 16, we are going to use 16 number of addresses. We are going to get the 16 number of addresses. I'm sorry. And for the interrouter 2, because the maximum number of ports are 2, we are going to get the number of addresses 4. And lastly, the number of hosts that are available and can be used in the topology and during the configuration, which is 30 for human resource and ICT, 14 for operation, marketing, R&D, and branch office, and lastly is 2 hosts for the interrouter 1 and 2. Now, the default gateway, we are using the last number of IP address range in the last available IP address range, which is from subnet 1, we are using here the 200.0.41.30, and for the subnet 2.62, and subnet 3 78, subnet 4 is 94, subnet 5 is 126, and subnet 6 is 110. Sorry. So for the interrouter 1 and interrouter 2, for interrouter 1 and interrouter 2, there is no default gateway because the interrouter is basically a connection between two routers. For example, router 1 to the router 2 are using the interrouter 1, and from router 2 to router 3 are using the interrouter 2. That is why there are no default gateway, because the default gateway for each subnet will be going connected to the router itself. Okay, lastly, this is the host IP address range. The host IP address range is actually the range that we can use for each of the devices that exist in the topology. So from here we can see this is the host IP address range available for each subnet. We cannot go more than this subnet, because if suddenly the IP address range kerfuffle in the other subnet, it will output an error of inconsistency, because we know that the subnetting process are specifically designed or calculate for each of the subnet with the maximum number of computer or ports in order to increase the efficiency of the topology. Okay, That's all from me. I am Nur Iqbal Amali bin Alias from class JCS1105G. I am representing my group in the presentation of IP addressing subnetting. Thank you.
Hi, my name is Nur Shafinas. Now I will show the switch configuration. Press button enter and we can see the name of switch right now is switch. To enable the configuration, first of all we need to type enable. Then for the configuration, type in configure terminal. So now we are in configuration mode. To choose the host name to assign in for the switch, type in hostname switch 1. So here we can see the name change into switch 1. After that, type in line console 0, which is the password we were in since internet cable connect to console line 0. We can see the configuration change to config line, so now we need to set the password for the line. Type password Cisco, which is the password is Cisco. Then type in login. After that, exit the line, also exit the configuration. With type exit. After that, type in copy run start. After that, we will do the IP address for switch. We want to add it. So we can see the IP address. So we type in configure terminal back and then press enter. We have to put the VLAN. Actually, to put the VLAN, we must type int VLAN 1. After that, we can add the IP address for the switch, which is 200.0.41.1 with the subnet mask, which is 255.255.255.224. Press enter button. Type in no shard. After that, type in exit and exit it again. Then we have to make the connection access for the switch. The range for the switch for the fast Ethernet. So first of all, we need to type in configure terminal and then int range. So we can see fast Ethernet 1 until 24. So type fast Ethernet 0, 1 until fast Ethernet 0, 24. Press the enter button. Now we can see the configuration name change into config if range. After that, type in switch port access VLAN 1. and type and exit and exit it again. Type configure terminal back and type in int VLAN1. So here we want to set the IP address for the default gateway. We must type in IP default gateway. The IP is at fast internet 00, which is 200.0.41.30, and then exit and exit it again. That's all for the configuration for switch. Next, we will be proceed by our group mate. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Aziz Akmal bin Jamaluddin, and now I want to present about router setup. We will use CLI for this router setup and then answer all the questions that have been asked. First, we have to assign name for this router, which I choose router 1. For the enter enable secret, we will choose Cisco. For the password, we will choose Cisco 1. And another one, visual terminal password, we will choose Cisco 2. So this one we answer no, no, no. Next, for the selection, we will choose number 2. The first command, we have to enable the router, which is en. For the password, we have to enter, and then router 1 config t. And then we choose the interface, which is 0/0 to assign IP address and subnet mask. For the IP address is 200.0.41.30, and subnet mask is 255.255.255.224. After that, we use command no shut, and then exit from the config for the interface, and then exit again. After that, copy run stat. I think that's all for the router setup. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Haikal bin Khalid, and I will present the steps to configure the interrouter between router 1 and router 2. So firstly, we need to open the command line interface for the router 1. Then we type enable, type the password, and also configure terminal. Next, we need to identify the interface that we use to connect between the router 1 and router 2. So here we use fast internet 1/0. So we need to enter at the command line interface FA1/0. After that, we can type the IP address and also its subnet mask for the interface. Then we type no shut. So the command line said that the interface pass Ethernet 1/0 change state to up. But here we still can see that the dot here still in red color. So we need to configure the next router, which is router 2, in order to change it to green color. So it means that the interrupt is completed the configuration. So here we exit from the command line interface at router 1. Next, we will open the command line interface for the router 2. Here we use the same step as the router 1 we do just now. We tap enable, type the password and also configure terminal. Next, we will identify the interface that we use at router 2 to connect between router 2 and router 1. So here we use interface pass Ethernet 1/1. So we type at the command line interface FA 1/1. Next, we can type the IP address and also its subnet mask for the interface. After that, we will type no shut, and then it said that interface pass Ethernet 1/1 change state to up. And we can also see here that the color change to the dot color change to green. It means that the connection between router 1 and router 2 is completed. So next, considering we reach here, we also can interface configure the interface SE03/0 for the interrouter at router 2 to router 3. So here, okay, and then we type back configure terminal. Same step as we do just now. We we identify the interface, which is the SE030/3/0 for the interrouter at router 2 and between router 2 and router 3. So here we type at the command line int SE0/3/0. Then we can type the IP address and also its subnet mask for the interface. Then we type no shut, and then it said that the serial 0 3 0 change state to down. It is because that we still not configure the interface at router 3, same as the router 1 just now. And then that's all from me. Next configuration will be posted by my other group member. Thank you.
So we are moving on to PC and server IP address setup. The first one is we are going to set up IP address for the server, which is we insert the IP address 200.0.41.2, and then the subnet mask is 255.255.255.224, and then the default gateway for the server, which is 200.0.41.30. So next is for PC1. The IP for PC1 is 200.0.41.3. The subnet mask is 255.255.255.224, and then the gateway is 200.0.41.30. So we are moving to PC2, which is the IP address is 200.0.41.4. The subnet mask is 255.255.255.224, and default gateway is also the same, which is 200.0.41.30. Then for PC3, where the IP address is 200.0.41.5. The subnet mask is 255.255.255.224, and the default gateway is also the same, 200.0.41.30, because it is all in the same LAN. So the last one for LAN 1 is PC4, where the IP address is 200.0.41.6. The subnet mask is 255.255.255.224, and the default gateway is 200.0.41.30. So we are going to do the IP configuration for all of the LAN in our project with the specifically IP address for each of the devices. So for the last part is dynamic routing. we are going dynamic routing for router 1. We have to type enable and then config T. So next we are going to type router RIP, where is the step of doing the dynamic routing. Next we have to type version 2 for this dynamic routing, and then we have to insert all of the network address for all of the LAN. The first one is network 200.0.41.0. The second one is network 200.41.32. The third one is network 200.0.41.120. The fourth one is network 200.0.41.64. The fifth one is network 200.0.41.80. The sixth one is network 200.0.41.132. Seventh network 200.0.41.112. The last one is network 200.0.41.96. And then we are going to exit 2 times. And then we are doing copy run step. So done with the dynamic routing, and then we exit again. So now we are going to do the ping to see whether that is successful or not. So the first one, we are ping from PC0 to PC8, and then PC0 to router 2, and then PC0 to switch 5, and then PC5 to PC13, and then PC5 to PC13, and then PC4 to PC20, PC4 to PC20, PC4 to router 3, and then PC4 to PC19, PC4 to PC19.
So that's all from us. I, Muhammad Hazi Akmal bin Jamaluddin, represents my fellow groupmates, would like to say a big thank you for this opportunity that we had. Thank you to Sir T.S. Ahmad Kamaruzaman for guiding us with this whole assignment throughout this whole semester. Again, thank you and have a nice day.